In these problems, we're being asked to graph some square root functions that have a lot of stuff going on. There are extra numbers underneath the radical sign. There are extra numbers outside the radical sign. There are even numbers multiplied by the radical sign. All of these things change the location or the shape of the graph, but the process for graphing these things is pretty much the same. We're going to try to find the leftmost point, and that leftmost point is always going to be where what's under the radical sign equals 0. And then we'll just calculate the value of the function and take that for a y value. So let's start by making a chart for this first one. We have our x values and our y or function values, and we'll start with the leftmost point. We want to know what value for x is going to make what's underneath the radical sign equal to 0. Since we have a plus 2, we would put a negative 2 in for x. So I'll put that over here, negative 2. Negative 2 plus 2 is 0, the square root of 0 is 0, and then we add 7 to it. So the value we get for the function, or for the y value, is 7. And let's just go ahead and plot that while we're at it. Negative 2, 7. So right there. All right, now we need to just pick some more values. And remember, when you're graphing square root functions, it's smart to pick values that make what's underneath the radical sign a perfect square. So numbers like 1, 4, 9, 16, those are going to be great numbers. So let's see if we can make what's under here 1. What would I have to put in for x to make this part 1? Well, that would be a negative 1, because negative 1 plus 2 is 1. So I'm going to put in negative 1 here. That means the square root of this would be 1 plus 7 would be 8. So negative 1, 8. And you might already see we're going to get this same kind of shape, this tail that takes off a little bit steeply from left to right and then shallows as we go on. But let's get a couple more points. Let's go for 4 here. So for that, I'd need to put in 2 for x, because 2 plus 2 is 4. The square root of that would be 2, plus 7 would be 9. So the point positive 2, 9 is on here. It's right there. And then let's go for 9 here. We'd need 7. So that would be the square root of 9 would be 3. So 7. And then 3 plus 7 would be 10. So the point 7, 10 is also here. Whoops, right there. And once we've got that many points, we can go ahead and just sketch in our graph. And there we go. Let's try one more. This one's just slightly different because it has this 2 multiplied by the square root part, the radical part. What this does is it squishes or stretches the graph a little bit, but the process for graphing it is really still the same. We want to find the leftmost point, and that's the point where what's under the radical sign is equal to 0. In this case, that's just x under the radical sign. So if we put in 0 for x, that should be our leftmost point. So we'll put in 0, and 2 times 0 is 0, and then plus 3 is 3. So that's our first point, the point 0, 3. So right here. All right, now let's make what's under the radical sign the perfect square of 1. That's easy to do. We just put in 1. And while I'm at it, we can put in 4 and 9. These are all going to be pretty easy because there's nothing added to x or subtracted from it underneath the radical sign. When we put in 1 for x, we take the square root of that, we get 1. We multiply 2, we get 2. We add 3. That adds up to 5. So 1, 5 is one of our points. So 1, 5. And you might see already this looks a little steeper than we're used to. That's because of this multiplication of 2. But let's go on. Let's put in 4 for x. The square root of 4 would be 2. Times 2 would be 4. Plus 3 would be 7. So 4, 7. That would be, whoops, right there. And then let's put in a 9 for x. The square root of 9 is 3, times 2 is 6, plus 3 would be 9. So we'll get the point 9, 9 right there. And then we can draw that in. So what we get here is the same basic shape. It's just a little bit steeper than we're used to because of this multiplying factor out here. So that's a little bit more work with graphing square root functions.